This video is going to be all about parabolas. You can see three different parabolas here on the graph, and we have kind of our basic one here. And we're going to be talking about what would that equation be for what we call our parent graph, where would the vertex be, and what kind of shape would it have. And then we're going to look at how you can actually move that vertex. Maybe you move it over here to the right and down, or maybe you move it to the left and up. Like, what would that look like in terms of the equation? How would that equation change? And also you can see that two of the three parabolas actually are opening up while one is opening down. So how do you get that to happen? And then finally, you should notice that each one has kind of a different width. This is your standard width here. This is definitely skinnier or vertically stretched. And down here it's more like a vertical compression. So we'll take a look at how that happens as well. So let's get it on. The first thing we're going to do is we're going to take a look at what we call the parent graph of parabolas. It is the equation y equals x squared. Keep in mind that this parabola, which you can see right here on the graph, is going to open up and it's going to have a vertex at 0, 0, otherwise known as the origin. I've gone ahead over here and actually plotted some points. You can see them. So if you plug in a negative 3 times itself would be 9. So that would be represented here on this point. Or if you plug in a 2, 2 squared would be 4. So there would be your 2 comma 4 right there. So that would be your basic graph. There's going to be some other kinds of graph in what we call vertex form. You can see some of these equations over here. Looks a little intimidating or complicated at first, but what we're about to do right now is take a look at what these numbers do to this graph of the parent graph, how it's going to change it and make it look different. All right, so what you see here is I'm over at Desmos, which you can get for free on the internet, and I've gone ahead and I've graphed this equation. And you'll notice over here the equation is y equals a times the quantity x minus h, and that's squared, and then plus k. And once again, this does look a little complicated at first, but let me explain what the a, h, and k stand for. A, in this case, is going to be 1, so a is nothing more than a number. H is 0, so think of it as x minus 0, or just x, and then right now k is 0, so it's plus 0 on the end. So once again, a, h, and k are just numbers, except they're going to change here, and we're going to see what happens to the graph. Also, you'll see that I have h comma k over here. H and k are both 0, so that's 0, 0 right here. So I'm going to go ahead and I'm going to change h, and I'm going to make it into, say, 3. And what that equation would be now is x minus 3. And what you can notice is that vertex is now slid over 3 to the right. So h, if I move it, and I make it smaller, it's going to move it to the left. If I make it bigger, it's going to move it to the right. And whatever h is in the form x minus h, that h is going to tell us the x coordinate of our vertex. Let's take a look at k. I'm going to go ahead and move it back to 0 here. If I take k and increase it, you'll notice it takes our vertex, moves it up, and if I decrease it, it moves it down. So I'm going to go ahead and I'm going to make h into 2 and k into negative 3, and you'll notice, wow, that's actually our vertex. So our vertex will always be whatever h and k are as a coordinate. I'm going to go ahead and move them back to 0, 0 here. Oh, oops, a little bit off there. And I'm going to go ahead and I'm going to change the a value. I'm going to make a go up. So it's going up to 1.1, and you'll notice, hey, it's still opening up, but it's getting skinnier, or what we call vertically stretched. If I make it smaller, and this time I'm going to go a little bit less than 1, it's going to make it wider. Okay, and we would call that a vertical compression when it gets wider like that. If you make it into 0 itself, it's just a straight line. So just know that if a is 0, it's no longer a parabola, it's a horizontal line. I'm going to make it go negative. What? It's opening down. So anytime a is a negative number, it's going to open down. If I go ahead and get it farther and farther away from 0, so like negative 6, it's going to be vertically stretched. And if I make it, almost not quite 0, but maybe negative 0.5, you'll notice it's getting vertically compressed or widening up. So in terms of how wide it is, just ignore the negative sign and know that if it's between 0 and 1, then it's going to be a wider vertical compression. And if you ignore the sign, anytime it's more than 1, it's going to be vertically stretched. As always, if you like what you see, please like, comment, or subscribe. Thank you, and now back to part 2. So now that you've seen on Desmos what the effects of A, H, and K are, they're summarized up over here. The vertex will be at H, comma, K. If A is positive, it opens up. If it's negative, it opens down. Of course, if it's actually 0 itself, it's not a parabola. And here, this is the absolute value. So just ignore the sign. If it happens, if A is a number bigger than 1, it's vertically stretched. And if the absolute value of A is less than 1, it's vertically compressed. So here are those equations at the beginning. And remember, right here, even though I know it says plus 4, you need to think of it as x minus a negative 4. So in this case here, H is actually negative 4. That's this. And then K is going to be 3. There is no number out in front, so A is 1. So what does that mean? It means we're going to be opening up because A is 1, and we're going to be shifting the vertex left 4 and up 3. So our vertex will be at negative 4, comma 3. If we look at the next one, remember this is the same thing as x minus a positive 2, and that is why H is at 2. K is the number right here, negative 5. So our vertex is at 2, comma, negative 5. We'll be opening up because A is a value of 1, and we're shifting it right 2 and down 5. And now the last two are much more complicated. We have a positive 0.5 for A. That means we're opening up. Also, because this number is going to be less than 1, it's going to be vertically compressed or wider. And H in this case is going to be negative 1. And remember, it's x minus a negative 1. And then K is negative 7. So that's why it's shifting left 1 and down 7. And our final one here, it's a negative number for A, so it's going to be opening down. It's going to be vertically stretched. Remember, we ignore the sign here, and since 2 is bigger than 1, it's going to be stretched or skinnier. And then because of H and K being 3 and 6, we're going to shift it right and up 6. So that's how you can look at these equations and get an idea ahead of time through A, H, and K what that parabola is going to be and how it changes from the parent graph of y equals x squared. All right, the final thing I want to show you on this video is how to actually graph by hand a parabola. That over here is y equals negative 2 and then parentheses x minus 4 quantities squared plus 8. So the first step you always want to do here is you want to locate that vertex. And I'm going to go ahead and I'm going to say what A and I'm going to say what H and K are. So A in this case is negative 2, so I know it's going to be opening down, and it's going to be skinnier or vertically stretched compared to the parent graph. This is the same thing as x minus a positive 4, so that means my H is 4, my K is 8. So that's going to tell me right now my vertex is going to be at 4, comma 8. So I'm going to go ahead and find that on the graph. So 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. So there is my vertex right there, and I'm going to put a V by it. And from graphing parabolas before, if we know that's our vertex, we know there's going to be some symmetry. So if I plug in a 5, or if I plug in a 3, which are both 1 away from 4, I'm going to get the exact same y value. So I'm going to plug in a 5. So if I take 5 minus 4, I'm going to get 1. 1 squared is 1. Negative 2 times that 1 is negative 2, and negative 2 plus 8 would be a 6. So these will both be 6, so that means I'm not going to go up the full 8, I'm only going to go up 6, and those are going to be some points right there. Also, if I go up one more and I go down one more from 3, 6 and 2, because of the symmetry in this parabola, are going to have the exact same y values. So I'm going to plug in a 6. 6 minus 4. Well, 6 minus 4 would be a 2. 2 squared is 4. Negative 2 times that 4 would be negative 8, and then plus 8 is 0. Here we go. So there is my 2 comma 0, and there is my 6 comma 0. And at this point, I've gone ahead and I've graphed 5 points, so I'm good to go. So this is not going to be my finest parabola ever, but I'm going to do my best here. I'm going to try to connect them. It's going to kind of curve. It's going to come back down. I'm going to put arrows on the ends. And there we go. That is a basic graph of that equation. The final thing about graphs, sometimes you'll be asked, hey, what's the domain and what's the range? So domain means, well, what x values can I use in the equation? And the answer is anything. This graph, I know it's going down in both directions, but it's also going left here and it's going right. So my domain is anything, and we can signify that in different ways here. I'm going to say negative infinity, and x is going to be between that negative infinity all the way up to positive infinity. So in other words, it can be any real number whatsoever. Range. Well, my parabola stops here. This is the highest it ever goes, and that was a value of 8. So that means it can be anything that is less than or equal to 8. So y is going to be less than or equal to 8. So that would be my domain or range. So that's it. You now know the basics of A, H, and K and how to transform parabolas. I also hope you stick around for the next video because that's going to take that A, H, and K to different equations. It's going to be things like square root graphs and cubic graphs and absolute value graphs, and you'll see how it works there as well. Thanks for watching, everybody.